Hi everyone, and welcome back to another daily TidalCycles video. So we're back with where we left off last time, talking about defining functions, pattern matching, monads. And one of the things that I want to talk about is a little more on defining types. So for example, this heck type, let's make it have more than just a double. So we could say heck of A holds a dog of A. Okay. And so that A is a type variable. It's the same kind of type variable you see in a lot of type signatures in Haskell, where this, when it says A, that can stand for any type, literally any type. It's unconstrained. When it's constrained, that's like this, where it says M, and then monad of M, which is, so it's saying that the type here is constrained so that it implements this type class. Now, what are type classes? If you're familiar with object-oriented programming, think of them as like an interface. It defines the set of operations that has to be implemented. A lot of important things in Haskell are type classes. Monads are one of them, but things that you can do folds over, things that you can iterate over, things that you can fmap over. These are all just different type classes, and type classes are also used for the ability to read from a string, the ability to turn something into a string, and a whole lot of other really useful things. So, that all being said, now, so the way you read this is that we define a variable here on the left side, and then we can use it over here. Now there's no data here. This just sort of remains, there's the two usages are slightly different, because you basically would specialize it if you're in a particular type. So, for example, heck of double is going to be equal to dog. Like you can build one, and then the A on this right hand side here means a particular one of those things, right? So this is just giving a name, and then you would supplement it. Like, for example, you could say, heck of double. You could say, and then see, we do just copying from down below. So yeah, heck is a type that takes a type and returns a type. In other words, it's just a thing. It takes a type variable. Don't worry about it too much. And then we say data heck A equals dot, and then saying type double, and if I remember correctly, this should work. Oh. No, unfortunately, it doesn't. I was hoping for to do the more complicated thing, but it didn't. But yeah, double is a type, which means star here. Technically, these stars, they're called kinds, and this is heck is a type constructor that has different kinds, and these things on the right hand side of the definition, there's the actual like data constructors as opposed to a type constructor. This feels a little wonky at the moment, so I'm not going to get too deep into that. But what this means is, now I believe this should infer the right type here. So yeah, this all refer, inferred the right types. That's one of the nice things about Haskell. So if we check the type of this pet to mod function, what does it look like? Looks like this. It's a heck of a double. And how did Haskell figure out it had to be a double? Well, because at the end of the day, we used the D here inside a pattern that was fed to distort, and was distort one. It wants a pattern of doubles. So this is how type inference works. It takes the Haskell takes the data it has, and then it takes the data it has, and then it sees if it can construct a general type that would fit. In this case, heck of double. If we use something a little more generic, it may have been would have been like num A implies heck of A or something like that, right? It might have been more like this constraint syntax. Let me see, what else did I want to mention? So this heck type here. So now that we've made it polymorphic, I should tell you what it actually is. This is really just the type, maybe. And I'll show that in a second here. Oop. Maybe A is equal to nothing, or just A. And so please note, it doesn't actually matter what order these constructors happen. Not really. It doesn't really make any difference. But still fundamentally kind of the same thing. It has a polymorphic constructor, and it has one that has no data in it whatsoever. And maybe it's a wonderful type. It's useful for so many things. I personally think maybe would be a really good thing to use when defining kind of pattern algebra, like how patterns intersect with each other, right? And by using nothing to basically define a rest at a point in time rather than there just being an actual gap. That's a thought I've had about like alternative definitions of pattern and stuff. So with all that, now I want to say a few things about the monadic stuff I showed last night. So when I showed this function, it's actually a different way of writing it. And that is, it actually involves this function here that I called bind, the arrow equal thinger, right? So what this is that the do notation is basically just a syntactic shortcut for chaining functions together using this thing. And so what's an alternative definition of Hecker? Let's talk about that. Okay, there I typed the right character. There's a handful of characters. I alluded to this in an early video in this series. There's a handful of characters I tend to typo a lot because I use a tiny 40% keyboard, and I miss the chords, particularly when I'm tired. I know at least one yawn has made it through this video so far, but that's fine. These are just daily videos, and it's all okay. So yeah, what we want to do is say, so the alternative definition of Hecker is, let's look at this for a second. Let's put it up here. So we need, if we want to do this bind here, so rand is going to be the MA. Then what's the thing that is the rest of this? Well, this is actually this body here. If we think of this arrow as basically defining a kind of binding, right? Then we could also think of this as lambda r to, oh, and for those who aren't familiar, this is the way you do an anonymous function in Haskell. I don't know how much I need to explain anonymous functions, because in all the years since I was in college and first learning Haskell and languages like it, I feel like anonymous functions and lambda abstractions are like way more common than they were like 15 years ago. So that being said, so you can say lambda r goes to, I want to say if r is less than 0.6, then I can't even remember this silly function I defined. Ah, yes, okay. Return dog r else return cat. Okay, so that should be correct, and pretty sure it is. Let's just test it. Yep, it's the exact same thing. And like, in this one instance, it's actually kind of awesome to define it like this, right? It is. It's kind of cool. I feel like it sort of shows how this is composition of functions, but oh boy, can you imagine having to do this like chained one after the other, after the other, after the other? It would be pretty miserable, which is why there's do notation. And so instead of having the lambda r here, you say this thing here, which creates a new binding, and then uses the binding in the subsequent blocks. And yeah, it's all just, it all ends up being pretty straightforward. And that's just a little bit more about monadic syntax and a few things about creating type constructors. So I think maybe I will leave it there as another short lecturery video. Keep the number of concepts defined in a video pretty small. And we'll probably start applying this to make weird combinators to use in future videos. So hope to see you in that next video, and take care.